Hey there, and welcome. So, have you ever thought about how devices could connect to each other if there's no Wi-Fi, no cell tower, nothing? That's the wild world of ad hoc networks. And let me tell you, getting data from point A to point B in one is a real headache. But what if the answer wasn't some super complex system, but just thinking local? Today, we're jumping into a really smart solution for this called the Zone Routing Protocol, or ZRP for short. All right, let's get into it.
Okay, so first, let's get on the same page. An ad hoc network is basically a pop-up network. It's made of mobile devices that connect directly with each other, no central hub required. I'm talking about a rescue team in a disaster zone, soldiers on a battlefield, or maybe a huge network of sensors spread across a farm. The big problem? These networks are always changing. Nodes are moving around, so the paths for data are constantly breaking and reforming. Your typical everyday routing methods just can't keep up.
Now, here is the absolute key. The observation that makes ZRP possible. The folks who designed it started with one super powerful assumption. They figured, hey, most of the time, you're not trying to send a message to a device way over on the other side of the network. Nope. Most of your traffic is going to someone who's relatively close. And that one little idea, it's the foundation for this entire protocol.
And that simple idea leads us right to ZRP. Now, you'll hear it called a hybrid protocol. So what does that even mean? Well, it just means it cleverly smashes two different strategies together. It's proactive for nodes that are close by, meaning it's always keeping those routes up to date. But for nodes that are far away, it's reactive. It only bothers to find a route when you actually need one. So you get the best of both worlds, and it's all thanks to that idea that local traffic is what really matters.
So how does it pull this off? Well, think about it. Instead of trying to know the route to every single other device in the whole network all the time, which, by the way, creates a ton of traffic and eats up battery, ZRP just doesn't. It dramatically shrinks its focus. It puts all its proactive energy into a small, manageable little neighborhood around itself that it calls a zone.
Right, so this whole thing hinges on this concept of a zone. And let's be clear, we're not talking about a physical circle on a map. This is a logical area that's defined by the network itself. And really, if you can wrap your head around how these zones work, you'll totally get why ZRP is so slick. So let's break it down.
Okay, here's the official definition. A routing zone is just the collection of all the other nodes that are within a certain number of hops from you. And a hop is just one jump from one device to another. So, if your zone has a radius of, say, 2 hops, that means it includes all your direct neighbors and all of their direct neighbors. Pretty simple, right? And there are a few key things to know about these zones. First, every single node gets its own personal zone. The size of that zone is set by its radius, which gets the fancy Greek letter rho, and it's measured in hops. And here's the really clever part. The zones of nodes that are next to each other overlap. That overlap is exactly how the network can pass a message from one zone to the next if it needs to find a route to someone far away.
This diagram here gives you a little peek under the hood at the architecture. You can see how it's built with different parts for handling things inside the zone versus outside the zone. You see things like IARP and IRP. You don't need to memorize the acronyms. The big takeaway here is just that it's a really well-structured, modular design that makes this whole hybrid strategy work.
So what's the big payoff for all this? Well, because you're only actively keeping track of a small handful of nodes in your immediate area, the job of keeping your route information up to date becomes way, way easier. You're not burning precious processing power and, more importantly, battery life to track distant devices you'll probably never even talk to. And for a device out in the field, that's a huge deal. It means that phone in a rescuer's pocket lasts longer. It means that remote sensor can keep running for weeks instead of just a few days.
You know, the source material really just nails the benefit with this one quote. By focusing on that local zone, ZRP slashes the amount of wasted effort. It makes sure that the energy you spend maintaining routes is almost always for routes you're actually going to use. It is all about being smart and efficient.
So as we wrap this up, the big idea behind ZRP really leaves you with a cool thought. In a world full of massive, complex, sprawling networks, ZRP shows us that sometimes the best, most efficient solution isn't to try and know everything about everyone. It's to just focus on what's right in front of you. Makes you wonder, what other giant problems could we solve if we just took that same local approach? Thanks for tuning in.